Welcome to the series. Here we perform hands-on exercises with OpenAI API and Python. In this series, we'll cover the OpenAI Embeddings API and its usage in two parts. In this video, which is part 2, we will follow these steps. First, we'll load a custom dataset in the form of a CSV file. Second, we will calculate the embedding cost. Third, we'll create new embeddings out of the custom data we loaded and generate a new CSV file. And lastly, we'll use the vector embeddings to perform cosine similarity searches. Now let's get started. All right, so let's start with installing the necessary libraries. In this case, OpenAI, NumPy, Pandas, and TikToken. All right, now that it's done, let's move to the next step, key setup. Simply set up this environment variable, OpenAI API key, replace this string with your own OpenAI API key, hit this button, you're done. With that, this is a helper function. I'm replacing the print with myPrint. And in the previous video, we talked in detail about this. So I'm not going to go over this again. So that's done. Now let's see what we'll be doing in this video. We're going to load up custom data as a CSV file. We're going to calculate tokens, calculate the embedding cost, prepare the new CSV file with new embeddings, display the file content, convert the embedding strings using NumPy, and then perform similarity search. So let's get cracking. All right, so let's load up our data file, which is right here. I loaded it up. And here I'm just going to use the pandas, which I'm bringing in as PD, pd.read CSV, and our local file, and then display it. So this is the content of our file. Basically looks like a bunch of random words, but if you look closely, you'll see that there are animals, colors, and some sort of a drink in here, drink name, right? With that done, let's go to calculating tokens. Now this is something I covered in the previous video. Please check out part 1 for details, but here I'm just showing the methodology behind calculating the number of token in a string like this using TikToken and the OpenAI embedding model. This guy right here. Let me run this. So this is the tokens look like. These are token IDs, and number of token in this sentence, in this text, is 4, right? So now let's move to the next step. Using that methodology, we're going to go ahead and calculate the number of tokens in the text column of our data CSV file, which is this guy right here. This text column we're bringing in and creating a list and putting in this variable called words, then taking this word and calculating the total number of tokens using this object that we created using TikToken and following the same methodology. Once again, this is also covered in the part number 1 in detail. Please go watch part 1 if you want the details of this. And that being done, we're just estimating the cost. I'm running it. And there you go. This is the content of our file. We have total of 41 tokens, and this is the estimated cost. With that knowledge, let's go to the next step where we prepare our new embeddings. All right, so this is where we prepare our source data into embeddings. And with that embeddings, we're going to create a brand new data file, which is another CSV. And the way we do it is by creating our own little embedding function, get embeddings, create a data frame using our source file, words.csv. And then we create our client with OpenAI. And here comes the get embedding function. It takes the text and the model, and once we take the text, we do some cleanup by removing the new line character from the end, and then we send it to this function to get the embeddings. Now, I'm not going to go into too much detail here because I've covered this in much more detail in part number 1. So if this is the first time you're seeing this, please refer to part number 1 for details. So what's happening here is the client we created, using that client.embeddings.create, we're passing the text, the source text, and the model, and then whatever it returns, we are returning the actual results using .data0.embedding. Basically, we're sending text and getting embeddings back. Simple. And with that, and now that we have a data frame out of this word.csv, we're creating another column called OpenAI embedding. And in here, we are passing the text column that we created before, which is this guy right here. So this is our source text, this column. And using this text, I'm using this lambda function and sending this text content as X and passing to get embedding this function that we created to get the brand new embeddings back and filling this column up. With that done, I'm using that df to CSV, basically using this data frame to write and create this CSV file with these two columns, text and OpenAI embeddings. So when I run this, this file should show up right here. So I'm going to go ahead and run it. All right, looks like it was successful. So let's see. There you go. That's our file. Now that we have our file, so let's see how it looks like. Simply, we're going to use the same PD or Panda object to read this CSV. And look at that. Now we have all our words just like before, but beside it, we have also all our embeddings. But there is a problem. To perform similarity search, this is not going to work because this is a string representation of our embeddings, right? So with the string, we cannot really compare. And that's where this section comes along. Now we use NumPy, right? We take that data frame and this column, this embedding column, as it says here, OpenAI embedding, we take that and we apply eval and then apply np.array. Now np is basically the NumPy that we brought in. Let me just run it again. So now we're going to take this data as string and turn them into NumPy array so that we can compare and perform a similarity search, right? So let me run this. All right, so it failed because it's looking for the reference of this. So I have to run it again. All right, now let me run this again. And there you go. Now, even though they look the same, they're not really same. These guys are now numbers instead of strings. So now we can move to the next step where we perform similarity search. All right, this is the last part of the puzzle where we perform similarity search. Normally, we could get just OpenAI embedding utils and get embedding function, cosine similarity function, but from this OpenAI version 1.0, they disappeared that library and there is no sign of replacement. So that's the reason I had to bring in cosine similarity function from this library and went through all that work just to perform the similarity search. Here, basically, we are our search term is dog. Let's say we're going to look for dog. So what we do, we first create the search term, convert it into vector, and convert that into an NP array so that instead of string, it's going to become a NumPy array, just like we did here. And we also had to use this reshape stuff just because we are sending a one-dimensional array, but this cosine similarity library returns in 2-dimension. So that's why we had to do this extra stuff. And then we create a similarity column using this OpenAI embeddings as a source data. This is the source data, and this is where we compare our search vector with the OpenAI embedding vectors. And then we had to flatten this data so that they come in single digits. They don't come in a two-dimensional array, which this cosine similarity function actually sends. And then I had to use this display helper function, these two, just so that the display looks within the boundary, it's not broken or anything. And then I had to sort by similarities. Basically what I mean is, since I am looking for dog, so dog should show up at the top, right? That being said, let me run this and you will know what I'm talking about. Boom, looking for dog, and look, because of this ascending to false, I have dog at the top, and look at this similarity number. See, this is the column that we just created. And just quickly, if I didn't flatten this this data, just wanted to show you what it looks like. Let me just disable this and run this again. See, it comes as a two-dimensional array. Looks ugly, right? So, but as soon as we flatten it, run it again, boom, data is clean. And here's the similarity number, 1, which is 100% match for dog. And then the rest is cat, wolf, monkey. But look, farther it goes, the color blue, coffee, etc. goes farther and further, right? Because they are not even close. So next, let's do a search on the color blue. Let's see what comes up. All right, see, 100% match with the blue, but now the closest friends will be the colors. And let's see what coffee brings us. All right, once again, 100% match, but look at its friends, tea, beer, Coke, iced tea, etc., etc. But farther it goes, the animals and the other stuff shows up. So with that, I conclude the part 2 of this mini series